This is Geometry 7.5. We're going to use triangle similarity to prove some theorems about triangles. The one that we're discussing here is if a triangle has a parallel side that goes through it. It's not necessarily a mid-segment. It's not necessarily touching the midpoint of both sides, but it is parallel. What this shows us is that we would have two triangles that are similar to each other because corresponding angles, when you have parallel lines, corresponding angles are congruent. That's something that we've known from before. If lines are parallel, then corresponding angles are congruent. That's what we would have here. We'd also have it on that side. We'd also have this angle here, which is part of the small triangle. It's also part of the big triangle. So we have a 1 ticker in both triangles, and we have a 2 ticker in both triangles. Now, a line parallel to one side of a triangle, it's parallel to this side, divides the other two proportionally. So we're going to show that A over B is equaling C over D. That's going to happen when we are dividing a triangle sides by a parallel line. It's going to divide the sides proportionally. Here we have that. We have parallel sides, so we know that we're going to have RQ over QU is going to equal RS over ST. Often we would say QR over the long side, the small triangle and the big triangle. Usually we have to draw these separately. But in this case, it's dividing it up, and we want to see what those values are separately. So QR is 10. QU is what we're looking for. RS is 12. And ST is 6. So we could cross multiply. That gives us 60 times 12 QU. Divide by 12, and that gives us 5. QU would be 5. You shouldn't draw a line over equals. So if this was 5, 5 times 2 is 10, 6 times 2 is 12. So that's showing the proportional aspect of the sides being the same way. And we can do it again down here. Determine if the lines are parallel. Are the lines parallel? Well, looking here, it doesn't really look like they're parallel, but let's take a look at the numbers. So we're going to take PQ. We're trying to decide if these lines are parallel. If the lines are parallel, then they're going to divide the sides proportionally. So we're going to take PQ and QR. We're going to equal that to PT and TS. So PQ is 18, QR is 38, PT is 36, and TS is 80. Well, that's interesting. We don't have anything to solve for. We're not here to solve it. We're here to see if the lines are parallel. So are the ratios the same? Do they reduce into the same numbers? So we could spend some time reducing. Another way you can check to see if they are the same is if you cross multiply, do you get the exact same value? Let's try that up here real quick. If this was a 5, then we would have had 5 times 12. and this is 6 times 10. They became the same result because this proportion was accurate once we calculated that it was 5. Well, is this proportion accurate? 18 times 80 and 38 times 36. Oh, they're not the same. It does not equal 1368. Well, that's what the lines implied. They didn't look parallel, but how could we show that it wasn't parallel? Because the cross multiplying doesn't equal each other, that means this proportion is not accurate. QT is not parallel to RS. Quick and easy. Good job, everybody.